Policy instruments are a critical tool in enacting significant, lasting change at a systemic level. Here, we describe 3 different policy measures based on existing regulations that have been proven successful in reducing emissions on the road, in factories, and in airports that may be plausibly implemented in the Bay Area to mitigate the detrimental effects that air pollution has on Berkeley students and the greater community. The first policy is a cap-and-trade scheme to reduce factory emissions. California has an existing statewide cap-and-trade system which operates under the following mechanics. First, a cap or quota is set to limit pollution across all factories to a designated quantity. Then, with each factory having a given number of permits or allowances, indicating how much pollution they are individually allowed to emit, with the sum of all emissions equal to the cap, the factories can participate in a market in which they can sell and buy allowances to and from each other. We are proposing a separate local cap-and-trade program exclusive to the Bay Area. One equity concern that arises from the statewide system is hotspots of pollution that emerge in urban centers, like the Bay Area. By implementing a cap-and-trade scheme locally, outside factories can't sell their allowances to factories in the Bay Area. The second policy is an odd-even day scheme to reduce vehicle emissions. Between November 4th and 15th of 2019, the Delhi government rolled out an odd-even scheme, in which odd-numbered and even-numbered vehicles, based on their license plate numbers, occupied the roads on alternate days in order to restrict the number of vehicles on the road. We propose to implement a similar strategy in the Bay Area. Such a policy would actually have other positive externalities, such as mitigating the traffic congestion that has always been a major problem. It might also encourage local public officials to invest more in public transportation, which can have long-term benefits for the Bay Area not only in terms of reduced emissions, but also because improved transport systems can encourage several factors that promote equity. The third policy is airport efficiency management. We need to increase airport efficiency in the Bay Area specifically because there are 2 major international airports, both of which are huge contributors to local and global air pollution. The Oakland and San Francisco airports operate with very high levels of inefficiency, for example through aircraft idling, resulting in increased particulate matter emissions. Fuel combustion in aircrafts is a generally efficient process, and jet exhausts have relatively low smoke emissions. The problem lies in the pollutants that are emitted from aircraft at ground level, hence idling is a major concern. Additionally, the surrounding traffic generated by the airports also produces a significant amount of air pollution from vehicles. Based on the empirical successes of these measures in other settings, their implementation in the Bay Area can be extremely effective in combating local air pollution. California's cap-and-trade system has led to a 5.3% reduction in greenhouse gas emissions from the start of the program in 2013. Furthermore, the odd and even day scheme has reduced particulate matter concentration in Delhi from 428 to 380 micrograms per cubic meter over the course of the 12 days that the policy was implemented. Moreover, analysis of airport efficiency using particulate matter trackers indicates that around 80,000 individuals are affected per microgram cubic meter of particulate matter, making airport management a very important tool in reducing people's vulnerability to air pollution in the Bay Area. Policy instruments can create lasting systemic effects. The success of these combined policies suggests promising results for their implementation in the Bay Area to mitigate the detrimental effects that air pollution has on Berkeley students and the greater community.